Good morning and hello, a warm welcome from my side to today's webinar related to Lean Six Sigma and how it beneficially applied in the QC laboratory. So also welcome to our guest expertise, Dr. Christoph Lustenberger, as CEO and co-founder from Stetig Besser and a lecturer from the Zurich University of Applied Science. He's a black belt in Lean Six Sigma and a deep expert in smart factory and lean management. So hello, Christoph.
Hello, Philip. Nice to be here. Thanks a lot for the invitation.
Thank you very much. So we know each other for a couple of years now and working together on a different kind of projects. Maybe you can also say some words about yourself.
Yeah, so I'm Christoph Lustenberger, the founder and managing director of the company Stetig Besser. Since about 5 years, in parallel lecturer at University of Applied Science Zurich for factory management automation. And my background is about 20 years of industrial experience, mainly in the food industry, but also in the online printing industry.
Thank you very much. Thanks for the introduction, Christoph. From my side, my name is Philip Osterwalder. I'm the CEO and co-founder of OneLimbs. I'm a skilled and passionate lab technologist, biomedical engineer and environmental engineer, and co-founded OneLimbs as a SaaS application for laboratory digitalization with the services of quality digitalization since 7 years. So let's hop into today's agenda. Just some general information for today. So we record this webinar and we'll upload it so you can look it on demand to a later state if you miss some parts. If you have some questions during the webinar, just paste it in the chat. And if we have enough time at the end, we will answer them directly by me or by Christoph. If you want to have the slides from the presentation you see today, just send us a request by mail and we can provide it to you. If you want to have any other questions or more information about OneLimbs or Stetig from Christoph, just send us also a mail to hello@onelimbs.com. Let's hop into the agenda for today. So it will be a packed half an hour, and the last 10 to 15 minutes we will use for your questions. First, we will start with the challenges in the laboratory, especially in the quality control, quality assurance laboratory. Then Christoph will do an input based on the focus Lean Six Sigma and the application in the lab. So intro about lean management and Six Sigma, what's the basic terms and what is so kind of the survival kit to know about these two terms. The improvements and the added value, how it can be applied, and what will be the benefits out of it by applying it. And at the end, I will present some best practices by using lean tools and Six Sigma tools and some case studies from our side by laboratory digitalization. So first of all, what we face every day in the lab, we have defined some most important challenges and problems. Maybe you can reckon some of them. You see it also on the wallpapers on the right. So error-prone and complex processes are one of the most important things we face because of organically grown structures in some companies. They grow and they be used. And one of the most terms we hear, maybe Christoph can approve that, is we did it every time. We do it a long time ago like this. And why to change? Because it works. So this is one of the biggest problems. Also, fragmented and unstructured data. So raw data sheets, a lot of different Excel sheets, spreadsheets. If a lab technician or person changes, an employee changes in the lab, they're creating new templates, using new tools, new processes, and that gets unstructured. and needs a lot of time and effort to put this all together and bring them on the one page to evaluate. This brings also, or is deeply connected to the next point, is insufficiently connected and isolated data. Maybe you heard the term, so isolated data. We have a lot of equipment, lab devices, we have a lot of data sources from ERP, for instance, for MES, or from CRM tools. They all have quality data, which are also important, and devices, which we do some analysis, are important, and how to bring them into one system, to use this system then to evaluate and elaborate the most important information, to create certificate of analysis or test reports, is a lot of effort. Another point is the lack of control over the data and the flow. So how is the data formatted? Are they in the same structure? Can they be used as they are? Or do I have to be some kind of different in the formatting and so on? This is kind of a big problem. And the next point is the traceability about processes and also about the data. Who did the data, who created, who did this analysis, who created the report? How is this traceable? And we know a lot of companies, they struggle with audits. So they shut down the laboratory a couple of days or even weeks before an audit to get everything done and in a correct way for the audit. And then the rest of the 50 weeks in a year, they're working like hell and creating kind of the mess they clean up weeks before the audit. So they're kind of the most important challenges we face in the lab together with our clients. If we scope out and zoom a little bit out to get a big picture and an overview about a digitalization, or even to make it a little bit more bigger, to a transformation in a laboratory or even in a company, we face some bigger problems which can face to issues or uncertainties within a transformation. This can be, for instance, a missing strategy or a story to tell the employees why we change, what's the vision, the goal. And maybe here, you know, the golden circle from Simon Sinek, to find your why. This is a key pillar to have a strategy and a story. And I think also Christoph will give some inputs about this. Another point is a qualified person or even a personnel which is not trained or informed as it should be. So a lack of qualified personnel. Add to a lack of sufficient investment. That is too less investment, and it's split up in several parts, and it's not continuous process. And then it get lost about the motivation of this transformation. So this could be also a work stopper for a successful digitalization. Communication is one of my personal biggest learning with all this digitalization journey, that teams and also internally communication is one of the most important parts. To communicate in the right way, to communicate in a sufficient way, and share the most important information, or even more than that, on the same level, or even with the responsible person. Human factor is also one of the key pillars to take all the employees within on the journey to this transformation and digitalization approach. And different cultural backgrounds and cultural change is also a key pillar. And from my point of view, I think Christoph will touch some of these key pillars, which are the basic foundation of this transformation, also key pillars for Lean Six Sigma. From our side, just to start and hand over to Christoph, I want to share our method, how we're going to proceed and is our approach to start a digitalization project for laboratories. First, we do an analysis. And about this analysis, we will share some key tools out of the Lean Six Sigma toolbox and how we're going to do this, and then how we can optimize processes and implement and apply in laboratory The third phase within our digitalization approach is digitalization of these operations together with our One Limbs platform. And the last phase within this digitalization onboarding approach is care and support from our side. So user and technical support, and also best practice care and exchange of knowledge and access to our expert board. So this was a quick overview about the starting and heading into challenges and problems within laboratories and their digitalization journey. Now, I'm a pleasure to hand over to Christoph to share some insights about the Lean Six Sigma toolbox.
Okay, thanks a lot, Philip. I'm just
Welcome.
sharing my screen, and we can start. You see my screen now? It's okay?
Yes, I can see your screen.
Good. Okay. So I welcome you from my side to an introduction about Lean Six Sigma and also the relevance and how it can be applied in a lab environment. Lean Six Sigma, we will break it down into the two terms. First, to get to know what lean means, and it's about decreasing throughput time, to take it already upfront now. And then we break it down to the other term, Six Sigma, which is about reducing process variation, producing more products within specifications, and therefore reducing defect rates in a production or lab environment. And last but not least, I will close at the end with success factors applying Lean Six Sigma principles in a continuous improvement environment. And Philip already touched before on some of these points. They are more the soft structural culture points where Lean Six Sigma, we concentrate more on the mechanics. Good, let's start and dive into the Lean Six Sigma topic. And when we do so, we normally get confronted or challenged by the triangle time, quality, costs, with which all companies are faced with. And the companies need to deliver products faster, need to deliver products on time in regards of time. The customer wants to have it on a very high quality, achieving their specifications, wants to make sure that it's traceable if needed, that we can follow back on the product. And last but not least, it's also about costs. And this triangle is put into the environment where this factory or production place is producing. And this environment also gains or wants some sustainability as a beneficial impact on the environment. So that means that we need to build up factories, production places, lab places in a sustainable way, using renewable energy, having a value creation in regenerative systems, etc. Now, this is kind of the where we start, independent of what we produce and do in our company. And now the question is, okay, good, but now where is Lean Six Sigma coming back into this game? And this is where, right? So Lean is about time and throughput time, and how we can create throughput time in the most efficient way. We will see what that means later. And quality is linked to Six Sigma, where we want to reduce our process variation, getting more stable processes, and therefore producing within specification and having as low defect rates as possible. So we pick lean first. So the green dot on time, and we dive into the lean and then into the Six Sigma later. So we already learned that lean is about throughput time, process time. So when we have a process, is it in the lab, in the production, in the administration, we normally analyze the process, and then we have a starting point of a process. The process runs with the product, the information, or both, and then the process ends. And during that time, we have uh, measured during our analysis two major things. First, cycle times. These are the blue bars where we add value to the product. For example, we do a lab analysis and we add the data to the system. When we are not sure if what we are doing is adding value or not, we can just ask our customer. Our customer is willing to pay for what we do, it's added value. If our customer is not willing to pay for what we do, it's not adding value. It's basically that simple. And if it's not adding value, it's on the orange bars. Typical non-adding value things for which the customer is not willing to pay are waiting times, transportation times, and so on. And that in total then sums up to the total throughput time. And now the lean target, so the major focus on lean is to reduce this throughput time from where it is now to only adding value time. So our vision is, and we all know that's not possible on the even on the long run, but it's our vision or our North Star to reduce our throughput time to only adding value time, the blue bars, and therefore we have shorter throughput times. We can deliver the product way faster, and we use way less waste and wasting time during the whole process. We all know that we don't get there from today to tomorrow. So that's why we run from throughput time before to our vision throughput time, base case throughput time, with only adding value after in small steps along the PDCA cycle. Most probably all of you know from Deming, plan, then we do check, act, and in small intermediate steps, we run from top to bottom and getting better always a little bit, time by time. So let's take a lab example, how that could look like. So every process in the lab, in the administration, in the production, we can analyze and measure the throughput time and then divide the throughput time into adding value steps and non-adding value steps. When you run through the process, always imagine that you sit on the material being analyzed. So you come in and as a material into the lab, you get stored on a stock, on a shelf, then you stay there for a certain time. So that's the first orange bar. Then after this certain time, you get analyzed by a little bit more than 30 minutes. And then you get on another shelf and you stay there for a day or so. Then somebody comes back into the lab, takes you off the shelf with the paper. The person who analyzed you put the numbers on the paper on a manual way. That person takes the paper with you as the sample and types the paper data into the system. That takes probably not that long, probably only a minute or less. And then you get put on another shelf in the lab and the paper gets thrown away and you sit there a certain time until the result is available for the customer and you get put somewhere else or you get refurnished. So that's how we look at the process also in a lab. And then we think, okay, what of this 2.1 day process it takes in this lab was adding value? So what for is the customer willing to pay? And if we ask the customer, he's saying, okay, I pay you for the lab analysis and I pay you for the data entry in a digital way because I get my data in a proper format I can use. So that ends up at the 34 minutes. The customer is willing to pay, but our whole process takes 2.1 days. And with that, we can also calculate the so-called lean index, which is the 34 minutes divided by 2.1 days. And we see how much percentage of our whole process time is adding value time. And it's about 1% in this case, which is not so uncommon that we are below 10%, which is the case for most of the time. Now, based on that, you can do what we saw before with the PDCA. You go into the orange bars, you break down your waste time. Why do we waste time here? Are we waiting? Do we have inventory stock and so on? And then we go and improve from here step by step along the PDCA cycle, plan, do, check, act, to get better and better and reducing our throughput time probably from 2.1 day first to 1 day and then less than 1 day and so on. And therefore we have way better uh, throughput times, way better reaction times to the market, and way better uh, um, how do you say, control over the process. So if something goes wrong, you see it way faster with smaller throughput times and can react way faster. So that's the lean term also in regards of a lab environment. Now we go back to the Six Sigma term, and we already learned that Six Sigma is about quality. So lean is about time and throughput time and making a process more efficient in regards of the time we use. And Six Sigma is now about the quality term, where we want to reduce our process variation to get things done within specification. We deliver to our customer, so we get a better, happier customer, and internally our defect rates get reduced, and we waste less material and money. Then the question always comes up, okay, what is good, a good rate we run within specification? And most people say, yeah, 99% sounds pretty well, right? So we run 99% of our production of what we do within specification limits. That sounds pretty reasonable good. And we would agree, yes, that's probably fine. If you think about 99%, whoops, what would that mean? And I pick only two examples of this slide. On the left side, if we have a 99% within specification or process within control limits process, that would mean that we would have two incorrect landing per day in a big airport. So if a big airport runs at a 99% level, we would have every day two incorrect landings. Or if your electricity supply runs at the 99% process level, we would have 7 hours lack of electricity per month. Now, we could say, okay, this is not good enough, at least not for all of the processes we have. So we need to go to a way better number. And I went now to a 99.9997% process, which is basically a Six Sigma process, which only has 3.4 million parts out of specification. And if we go to the same two examples again, if we would increase our accuracy that much, we would go from two incorrect landing per day in a big airport to one incorrect landing every 5 years in a big airport. And imagine you working at a big airport, that's probably where they are or even higher. Or you go from 7 hours lack of electricity to 1 hour lack of electricity only every 34 years, which is really good. And I'm not saying that every process has to be on the right side. It always depends also on the cost you need to spend on the cost you need to spend to get there. And it always depends also on your risk level. So for an airport, it's probably that high or even higher. And for electricity supply, it's probably not that high. But in Switzerland, I would even probably go there that it's almost there. But it's really not that everything needs to be Six Sigma, but it's about the decision of how much effort it costs to get there and how much risk you take not being there. So to the terminology, we already started to talk about Six Sigma. Six Sigma was the world-class process on the last slide, which means we have the 3.4 defects per million opportunities. On the left side, we were around 100, yeah, we were around 10,000, 1%, 10,000 defects. So we were between 3 and 4 sigma. So we had the left side process, which was around 3 to 4 sigma, and the right side bucket with 6 sigma. We see a lot in industry or in processing environments, these 3 to 4 sigma levels. And depending on the risk and the effort to spend, we increase from 3 to 4 in the direction of 6. But as I said, always thinking about the effort and risk you talk about. Six Sigma is a methodology which follows a very structured approach from defining the problem, really measuring the data, analyze the data, and then based on the analysis, making sure your improvement targets are clearly set up. Then you improve and you control your improved process so that it stays sustainable and long term at the new level. Beside the very structured 5-step approach, you have a lot of statistical tools you use, quality tools, and so on to make sure that you measure your data correctly and also analyze them according to statistical tools. And then you work even in the control phase with so-called control cards to stabilize your process and put some rules behind your process to keep it stable. Let's take a lab example. What is typically done with Six Sigma in the lab? So first, when we measure a process, we need to know that the measurement itself is also part of the process variation, right? And in the lab, we measure a lot of processes or material and so on. And in that regards, we have two major terms we use, accuracy and precision. And accuracy means how far off are you with the measured value, with the average measured value from the real value. And precision means if you measure the same thing again and again, how distributed are your measured values. And let's concentrate on the left side. Both of these processes are very accurate. So the average, so the target is in the middle, and the measured value, the average of all the red dots, the measured values is also in the middle. On the bottom, the target is in the middle. The average of all the red dots measured is also in the middle. So it's a very accurate process on top and on bottom. The difference is the precision. So we measure the same thing again and again on the top. We get the same value, very high precision. On the bottom, we measure the same material again and again, and we get distributed measurement dots. That means the precision is low. And in that regards, we observe and analyze with Six Sigma also measurement systems in the lab. As I said, the total variation is not only the process variation, which we call sample to sample variation, it's also added up with the measurement system variation. And the measurement system variation, as we saw, is put up or set together with accuracy and precision. Accuracy was how far we are offset with the average measurement from the real value. If that's bad, we have to recalibrate our equipment, our measurement equipment. and the precision was the distribution where Six Sigma comes in of all the measurements. And we even break down the precision further into repeatability and reproducibility. And when we do measurement system analysis, we really go that far down with our measurement to find out how much of our precision distribution comes from repeatability and reproducibility. Repeatability is we measure the same operator, measures the same thing with the same gauge over and over again. And how far is one operator measuring different things over time? So how is the distribution for one operator? And reproducibility is if different operators measure with the same unit again and again, and how far that distribution is. And that all together leads to a measurement system analysis compared to the sample-to-sample distribution, and we can make a decision at the end of this analysis if the measurement system is good enough for the process measurement, and if are there also opportunities to improve the distribution. Good. So these were two short examples for Lean and Six Sigma in regards of the lab environment. I shortly sum up with some key success factors in continuous improvement where we use Lean Six Sigma tools. It's about the commitment of the management is key. Always understanding the big picture. Philip already mentioned the strategy. Always involve your people, put them first in the change, key as well. If you don't do so, the chance that you fail is pretty big. Make small steps and learn from the small steps with the PDCA as I shown. And if you learn and go, you can then, when you're sure that you can implement and roll out and scale later on. Good. Thanks a lot for your attention. That was my short input. I hope you enjoyed it. And if you have any questions, I'm open to answer them later on. Thanks a lot.
Amazing. Thank you very much, Christoph, for this insightful intro and overview about lean management and Six Sigma. It's always, for me, it's always mind-blowing, the comparison between 99% and 99.9999%. That's kind of exponential difference and improvement. That's really crazy. Okay, if you have any kind of questions related to Christoph's input, just paste them in the chat. So I want to close with the last slides for today, and with the best practice and a case study from my side. So I think you can see my screen now. And we provide an analyze workshop together with Christoph based on 4 pillars we are using. They are kind of key metrics for our side. So first of all, a 360 degrees analysis. We call them holistic analysis to have a quality walk. This is called in Lean Six Sigma language Gemba walk through the value chain to identification of potential synergies, connectivity, work ethic, the value stream, and so on. Also we mentioned them a couple of times from my side in the intro, and also Christoph mentioned them, to involve all employees, to take up on the journey, to motivate them, and to share a common vision. They are kind of the overarching purpose to understand where we are going. These are 2 basics to create a customized solution, which is necessary to fulfill and pick up the needs and the requirements. And also, Christoph mentioned that to define the future state. This is also very important to know where we should go. And this leads to a fast and rapid implementation of a new digital solution in the laboratory, which has an action plan, defined milestones with clear recommendations of using Lean Six Sigma tools to improve the operations and improve the efficiency and effectiveness of the laboratory. To give an insight how and what we can get out of the laboratory, to have a multi-moment analysis to know who did what and in which time. You see kind of a pie chart, and the two colorized areas are related to data administration, and the results, the evaluation, documentation, archiving, and reporting. And together are nearly 50% of the working time of a lab technician. That means that 50% of the effective time of a lab technician are burned for data administration and data management. And if we can see this kind of a bottleneck and can detect this, this can be reduced by a digitalization and optimization of the operations and an automation of this kind of donkey workflows, daily routines. These are one kind of tools we use, and at the end we ask always how much value is created by do this data management. It's necessary, but it can be reduced for the effective work time. And to also show kind of a tool we use a lot is called SIPOC. SIPOC is a shortcut for stakeholder input process output customer, and it determines and split up the most important workflows and processes in different kind of steps. And within this, we detect the media breaks. If data is changing from paper into an Excel, and then from Excel into an ERP system or in a LIMS, and we can see these media breaks and define them, colorize them, and make a better plan how we can reduce these media breaks and make it more effective within this process. And this is an example, real-life example from a customer. There are time-consuming QM and QA processes. They are the most important ones for this company. A big challenge is the overcoming of media discontinuities, because this needs a lot of effort and time. And some bigger point is the order entry is done manually. So they have to fill out a form, paper, they send it or scan it and send it by mail, and then prepare the samples. And also to have an insight of what Lean Six Sigma analysis tool before digitalization or transformation can bring to you, we make a layout and a process map of all of these. Next to SIPOC, we quantify these processes. We define what is used in the IT infrastructure. What's the key metrics, for instance, of this quality control laboratory or quality assurance laboratory? In this example, there are 3 employees. They're using 10 lab devices. They have between 10 and 15 methods and roughly 10,500 samples per year they analyze. And roughly 2,000 samples sent externally for conduction or analysis in a service lab. By estimating, together with the client, that an assumption, for every sample, they're using 5 minutes for the data management, data administration, the protocol reporting, and the calculation of their of different kind of analyzed values, they need 5 minutes. This is summed up for all their samples to 90 hours per week in data management. This leads to 75% of the work time of 3 lab technicians, of 3 FTEs, full-time employees, are 75%. And this leads to roughly costs for 30,000 euros per year. They can reduce. And we can show up this and how we can reduce this with which kind of method and solution on a digitalization of these operations. To have this more visual, what they change within this, so they have a better sample preparation work area. where they use OneLIMS platform to create their labels and QR codes, pre-define this and make this sample preparation more faster, and then create a working desk with an iPad and OneLIMS where they can work very fast to elaborate and count their colonies for microbiology, scan it to take a picture and enter the colony values directly in OneLIMS. They will calculate it, and the lab manager afterwards can then validate and approve this analysis to create the report instantly. So they save a lot of time, and they can do right now 5 times more samples, and they saved roughly 60% of their budget in the quality management. We have it here in terms. For the implementation, increase the workflows by over 50%, error reduction by roughly or over 80%, and they have a paper reduction to be more sustainable by 90%. They get rid of all these forms and paperwork. So from my side, let's head over to the Q&A. If there is anything you want to know from Christoph, just type it in the chat. To one more information from my side, to have a sneak peek to the next webinar will be on the 8th of May. Will be from 11 to quarter to 12, and it will be about automation. And we will have another expertise out of our expert board, Roger Schelbert from Aurovis, which is focusing on workflow automation, robotic, and vision. And we have also a project together which calls Lab Pilot, and we will do a demo from Lab Pilot and an introduction about how can lab workflows be improved. If you'd be interested in some case studies from our side in food materials or about service labs for digitalization, just send a request and we can provide you with those information. And also, if you want to have a very quick overview about your digitalization fitness of your lab, just scan the QR code and do our quick lab check. It takes you roughly 5 minutes, and there are max 10 questions you have to answer, and you get an evaluation and an action plan with a lab digitalization guide from our side, which are related to your challenges, needs, and requirements. So let's have a look in the chat if there is a question. Otherwise, there is some typing. Let me. There is a question. Christoph, to you, what's the best advice by implementing Lean Six Sigma in a lab or in a company?
Yeah, I think I go back to the success factors. First, make really sure that your management, your company really wants to implement and stands behind the Lean Six Sigma path. Then create the vision, what exactly that means to the company, and put the right people into the driving seats, and then you get the right results. So it's not only about the mechanics, Lean Six Sigma mechanic, it's also about the whole surrounding, the management, the mindset, the culture, and putting the right people into the right driving seats is way more important than the mechanics. Because the mechanics we can learn and apply, the soft skills need to be there that it really works.
I can imagine. That's not the easy part.
No.
Of the journey. Okay, thanks for this. The next question is, when would you propose or suggest for a laboratory or a company to introduce Lean Six Sigma approaches, tools? Can you say that this is regularly for every kind of company they should use or set up their operations based on Lean Six Sigma? Or is it a certain point where you say up from this growth or big or size of the company, you should introduce Lean Six Sigma?
Basically, I would say it's for every company. And there's one exception if your company is really on a turnaround or very tough phases. We don't recommend to do Lean Six Sigma implementation. So imagine you have a turnaround, you're in red numbers, you're in big trouble, you have to reshape your whole organization. Then if you're there, I really do not recommend to do Lean Six Sigma because you're occupied with a lot of things, fast changes, radical changes. So your company needs to have a certain stability, certain grounds. But as soon as you have that, and most companies are there, it really makes sense to implement Lean Six Sigma. And then it's more about, do you want to do both? You only want to do lean first? How big you want to scale? And there we really recommend to start small, try things out on a small scale, make sure that you have quick results, quick earnings, and then scale from there. That's where we make the best um, expertise with. And with the first or second project, you learn that much where there's other opportunities that you can then over time with the first, second, third project also make a better plan for the year next year or the year following, right?
Mhm.
So the good thing about Lean Six Sigma is that it's mostly what we do is reversible. So we don't do like a 2 million invest in a big new equipment. And if you bought it, it's the wrong one. It's not really that reversible. The Lean Six Sigma stuff is mostly reversible. You can try out, you can fail, you learn, and you do it different, right? And you don't lose that much. And mostly you learn something.
Mhm.
And that's why I say you need a common ground, a certain stability, start small, learn from it, and then grow over time, year for year.
Nice. I heard it also that from my personal experience that lean management and also Six Sigma are kind of some used as buzzwords. Yeah, we know some lean techniques and we're using some lean tools, but there are just the basics and not even implemented very well. I think
Yeah,
this can also be some frustrating and cause some lack of motivation within the internal structure and also for the
yeah,
culture.
yeah, yeah. We see that often that, or we sometimes I cannot use the word lean anymore, and we need to and we need to use another word like operation excellence because it's already burned. And I'm coming back to the success factors, right? The mechanics we can implement, lean mechanics, Six Sigma mechanics, whatever.
Yeah.
But if companies fail or don't get it done, it's due to the soft skills. It's the management standing behind. Do we have a clear vision and a roadmap strategy to that vision? Do we really work day by day on this vision? Is the culture set up the right way to achieve this vision? Are the employees standing behind that culture? Does it make sense for them? Do they benefit from what we are doing as well? Not only the management and so on. And these are really the key parts and the key things you need to do right that you get it done.
Mm. Then
And you're right? A lot of companies say we have done 5S, DMIC, SIPOC, shop floor management, tuck, and then you go and see and you almost don't find it, right? Because it's not kept up in a sustainable way due to the missing culture, mindset, and all that stuff, which is key for these things.
mm, true. Okay, finally, question from an attendee from today. So, do you see or recognize any kind of future trends which are used in methodology, like Lean Six Sigma, or even in technology? So, you have a lot of insights in different kind of companies. And do you see any kind of future trend right now?
Yeah, I think the thing we see on the digitalization side is that digitalization hits Lean Six Sigma. Good for Six Sigma, it's probably less problematic in brackets. and it's kind of another mindset which comes in with digitalization and lean, but it's also complementary, right? With lean, we focus on people, learning step by step from the ground. With digitalization, if somebody comes in and says, let's measure everything, we have a lot of sensors, and then the sensors find out what is right, and when we put a artificial intelligence on top, and it solves the problem. Right, it's complete different mindset than lean. Let's work with the people from ground. Let's implement basic stuff step by step, getting a little bit better. But it's also complementary, and I think that's where we are going. We will work from both sides at the same time, right? We will work top down with digitalization, artificial intelligence, getting all the data, crunching the data, doing process optimization, even by artificial systems. And on the other side, we work bottom up with the people to get the daily routines, daily things, step by step, a little bit better. And I think putting that right together in the future will be a huge benefit for a lot of companies.
Nice. You say, you mentioned a very important thing to me. So if you want in the future to work with artificial intelligence, so the basics has to be right. So the data
Yes.
and the operations has to be right.
Yes.
And some of the basics can be done with Lean Six Sigma to build strong structures.
Yeah.
And then you can build up and use these operations and this data, this created data, to improve or enhance even a little bit more with AI.
Yeah.
Okay, I think that was insightful, packed with a lot of information, valuable information. Thank you very much for your time and also for the exchange, Christoph.
Thanks a lot.
It's a pleasure to have you and to exchange with you. And I want to close to thank you also, all attendees, for your time and attention, and also for these interesting questions to me and to Christoph. Looking forward to see you soon in our next webinar about laboratory automation. And if you have any kind of follow-up questions or want to have more information about digitalization and automation, or even Lean Six Sigma in the lab, just let us know and send us a mail. So have a great day and have a good week. We see us soon. Take care and bye-bye. So